All right, so we're going to take a look at the third week of material, okay, for trig. So last week we did the unit circle topic. Remember, the idea of the unit circle was I could give you a problem like this. Let's say the sine of 30 degrees. And then we figure out what goes in that box. Does anybody remember from last week what two numbers were in the coordinate for 30 degrees? The 45 was root 2 over 2, root 2 over 2. So it's not those numbers. Yeah?
It's root 3 over 2, 1/2.
Yeah, very good. Root 3 over 2, 1/2. And sine was the y value. So the answer here is 1/2. That's the kind of question we did last week. I gave you an angle, you filled it into the sine function, and then you calculated the answer of 1/2. This week, it's more like this. It's kind of the reverse question. So instead of me giving you an angle that you're going to fill in and take the sine of, I'm going to tell you the answer is 1/2. You have to work backwards from the 1/2 to figure out 30 degrees. So the first section that we're going to look at this week, 3.1, it's on what we call inverse trig. So it's exactly the opposite of last week. So what inverse trig is used for is it's basically used to undo regular trig. Right, so let me kind of show you an example. On the calculator, I'm just going to put it in degrees. And first, I'm going to do a problem like we would have had last week. Okay? Except I'm not going to do the unit circle. I'm just going to type it in on the calculator. Let me type in the sine of 28 degrees. And I get that answer. Now, what I want to do, I want to undo that. I want to take the answer that I have, 0.469, and I want to change it back. So I'm going to take, not the sine, but I'm going to take what's called the inverse sine. And I'm just, instead of typing in all those decimals, I'm just going to have it do the inverse sine of the last answer that was on the screen. So when I hit enter, what do you think I'm going to get?
28.
Yeah, I'm going to get 28. Because it's going to change it back. So it's kind of like if you took a number and you squared it, and then you wanted to undo that, you take the square root. Same idea here. If you take the sine of a number and you want to undo what you just did, we use what's called inverse sine. So usually you don't see the word inverse sine written out. This is the symbol for inverse sine. It's the same symbol the calculator uses. It's a sine, and it has a -1 up a little bit higher. Now there is another way to write inverse sine, just a different word, and it's arc sine. Okay, it means the same thing as inverse sine. I would say most textbooks use that notation. But arc sine means exactly the same thing. Okay. Just a different word for it. We also can do inverse cosine. So it's cosine with the little -1. Or you could also say arc cosine. And we can do inverse tangent. Now, I didn't explain as I did it, but the way that I got to the inverse sine, inverse cosine, and inverse tangent, I press second. That's how you do it on the graphing calculator. Press second, and then you can press sine, cosine, or tangent. That would be inverse cosine. All right, so any question on the name, like the abbreviation, or the button that you press on the calculator to get it to come on? So when we do inverse trig, let me just show you some different examples. Let me do, inverse sine of 0.2, inverse sine of 0.6, inverse sine of 0.8, inverse sine of 0.9. Okay, I just want you to see if you kind of notice what's a pattern. Put all these on a page. So I'm just trying to sample a bunch of values so you can see. Let's do inverse sine of 0.95. Inverse sine of 0.999. Let's even go really close. Inverse sine of 1. Anyone have a guess what that'll be?
0.90.
Yeah, that'll be exactly 180. So, and that's as big as you can go with inverse sine. If you try to do the inverse sine of like 1 point and just go a little bit over 1, it's not going to work. Can't go any bigger than 1. But you can see what happens as you get very close to 1, you get close to 90. You could do inverse sine of 0. That's okay. You get 0. And you can do negatives. Negative 0.5. Inverse sine negative 0.6. Negative 0.8. We're also getting close to a number going this way too. Inverse sine negative 0.999. What do you think the lowest answer I'm ever going to get is? Negative 90. And I'm going to get that when I plug in negative 1. Negative 90. If I try to go past it, let's try like negative 1 point, just a little bit past it. Doesn't work. Okay, you get an error. So when you do inverse sine, you will always get an answer between negative 90 and positive 90. That's how inverse sine works. It's always between negative 90 and positive 90. If you were doing it in radians, that's between negative pi over 2 and positive pi over 2. All right, let's try inverse cosine. All right, let's try a bunch of values and see if we can figure out what inverse cosine is between. It's not negative 90 to 90. All right, so let's try inverse cosine of 0. Yep, so we get 90. Inverse cosine of 0.2. Inverse cosine of 0.5. All right, inverse cosine 0.8. What's happening as the inverse cosine is getting, as the number in the parentheses is getting bigger?
Getting closer to 0.
Yeah, let's see what it ends up getting close to. Inverse cosine of 0.9999. 0.8. And then if I do inverse cosine of 1, all right, I get 0. You can't go over 1, just like some. You'll get an error. So we can go up to 1 for the number we plug in. Now let's try going the other way. Inverse cosine negative 0.1. Well, we're over 90 now. Inverse cosine 0.3. Oh, I meant negative 0.3. Okay, still getting bigger. Inverse cosine negative 0.6. Inverse cosine negative 0.8. Anybody have a guess how big it's going to go?
Up to 180.
Yeah, it's going to go up to 180. As you get closer and closer and closer to negative 1, it goes to 180. And then if you try to go beyond 180, it doesn't work. So when you're doing inverse cosine, and you hit enter on the calculator, the answer that comes up on the screen will be an angle, and the angle is between 0 and 180. In case I didn't mention it, that's what inverse cosine is. It helps you find an angle. Okay? in degrees or radians. It just depends what mode you put your calculator in. Okay, now, we could play around with the inverse tangent, plug in different numbers for x, but the answer that you end up getting is between negative 90 and 90. But look carefully. How is that different from inverse sine? It's not exactly the same. Yeah?
It can't be equal to whatever the angle is.
Yeah, it won't ever equal the negative 90 or the positive 90. Versus inverse sine, it will. Now I'm going to give you guys a chart. Let's look at the tangent column. And let's go to 90 degrees and see what it says. You're not supposed to equal 90 degrees. You're supposed to be less than 90. So let's see what happens if we equal 90. Okay, so look at the chart, if you can see it okay. Find 90 degrees in the angle column, and then go over to tangent. What does it say?
Undefined.
It says undefined. It can't equal 90. That is undefined. And it's the same thing if you look at it for negative 90 and you go to tangent. It says undefined. Okay. So small difference, but important that you don't put the equal to symbols when we do inverse tangent. But that gives you an idea of what the angle is always going to be between when you do inverse trig. It's either between negative 90 and 90, 0 and 180, or negative 90 and 90 for those three functions on the board. Okay. So let's try something. I got three different angles in the left. I just want to take the sine of each one of them and put it in the right. Let's start with the sine of 30. What do you get when you type sine of 30? Yeah, you get a half. Let's try the sine of 65. 0.91. Okay, about. Let's try the sine of 90. Yeah, we get 1. Let's try the sine of 150. .5 again. So that's a problem. The reason that's a problem is because now, if you want to take this number and go back, let's say you want to do the inverse sine of 0.5, taking a number in the right column, and it's going to turn it back to the number in the left column. Well, when you do inverse sine of 0.5, is it going to turn it back into the 30? Or is it going to turn it back into 150? Which one?
The 30.
Yeah, it's going to turn it back into the 30. When we do inverse trig, we only want to get one answer. Okay? There's lots of different answers I could take and get 0.5. Right? I could do the sine of 390. That's 0.5. I could do the sine of 410. No, wrong one. 360. Oh, 510. I added 510. There's tons of angles that I could take the sine of and get 0.5 as the answer. But when you do the inverse sine of 0.5 and you want to change it back, it's not going to give you 510. It's not going to give you 390. It's not going to give you 150. It's going to give you 30. How do we know which answer it's going to give us? Let's go back and look at this. When you do inverse sine, what did we say the answer is always going to be between? It's always going to be between negative 90 and 90. So look at all these answers that gave you 0.5. 30, 150, we had 510, I had 390. These could all be possible answers when you do the inverse sine of 25. But that's the one we got. Is there how many answers in this box are between negative 90 and 90?
1.
Just one. So the reason we pick these numbers, the reason these numbers are what they are, negative 90 to 90, 0 to 180, is because it will make sure you only get one answer. If we didn't pick those numbers that we picked, we could potentially get more than one answer when we do inverse trig. We don't want that. When you do inverse trig, you have to get a single answer. Okay? And it's not that these other answers are wrong. They're correct. There's nothing wrong with the other answers. But if we're going to only give one answer, we all have to decide on what answer that's going to be. And the way we picked these, that's exactly how the calculator does it. So the calculator has to decide what answer to give you, and it's going to follow those rules right there. And we're going to do the same. Is there any question on that? All right, so now I kind of did this at the beginning, so we already said this, but we did unit circle trig last week. This week, it's the opposite. So this is the kind of question you would have seen on the test last week. I would give you an angle. I'd give you a trig function, and I'd say fill the angle in and tell me what the sine of the angle is, so the cosine or the tangent. But the point is, I gave you the angle. Okay. This week, it's going to be the reverse. You need to tell me the angle. So I'll tell you what the answer to the question is. I'll tell you that the sine of something is a half. You need to figure out what's the sum. So that's what inverse trig does. Okay? It's going to help us figure out, it's going to help us find the angle. It's the whole point of inverse trig. It finds angles. All right. Any question on how what we did last week compares to what we're doing this week? Pretty much the exact opposite. All right, so let's try. We'll try an example. Okay, we're going to need a chart to do this, and I'll show you guys the chart. So I want to know the inverse sine of 1. Okay, another way of thinking about that question is basically saying the sine It's a pretty bad question mark. So the sine of what angle comes out to 1? I want you to tell me the question mark. What angle can you take the sine of and get 1 as the answer? Yep.
The sine. Wouldn't that be 90 degrees?
Well, let's check on the chart and see. So the way you use this chart to do inverse trig is look for that number in the sine column. Okay. So let's look in the sine column. And let's start with the left page of the chart. Is there a 1 if you go down the sine column?
Yes.
Yeah, what row is it in? Or you can just tell me the angle that's in that row.
90.
All right. Let's keep looking. Does 1 ever come up again in the sine column? No, doesn't come up again. So I circled, there's 2 answers when you zoom in. There's 90, which is the same as negative 270. How did I get all these ones that I wrote in parentheses by hand? Like, Does anybody see what I did to the angle to make it negative?
Subtracting 360.
Yeah, I just subtracted 360. So you got all the angles listed as positives and negatives, and I did the same thing with radians. Except instead of subtracting 360, what's 360 the same as in radians? 2 pi. Yep. So you have every angle as a positive and a negative from 0 to 360. Well, actually, 360 is a repeat of 0. So, same thing. All right. So now you've got two choices. The answer is either 90 or negative 270. What column were we looking at? Sine. And what did we say sine had to be between? Two angles. Negative this angle and positive.
Negative 90 and 90.
Has to be between negative 90 and 90. It's not that the other answer that I circled here is wrong, but we all have to agree on which answer we're going to use as the one answer. So which answer here is between negative 90 and 90? 90. Yep. So the answer to that, if they want it in degrees, is 90 degrees. What if they ask for it in radians? Pi over 2. You are not going to have to write both answers. Just read the directions, degrees or radians. Here the directions don't say. I'll tell you in general, when the book doesn't give you which unit they want you to use, they generally stick with radians. Right. So inverse sine of negative 1. Okay. Another way to think of that question. What angle could you fill in where the question mark is and have the answer come out to negative 1? Okay. Let's look at our chart. Okay, so go to the sine column and look for negative 1. Okay, where do you see negative 1 going down the sine column? Tell me the angle that's in the same row. Yep. Next.
270.
Yep, I see it there. Does it appear anywhere else? Negative 1. In the sine column? No. That one doesn't repeat. Okay. So you have two choices. It's either 270 or negative 90. What's the answer we're going to put? Yep, we're going to put the negative 90. There you go. All right, let's try this one. Inverse sine of a half. Okay, so kind of like I did up above, can someone tell me what is this question asking you? Like if you wanted to reword it in a way for somebody that doesn't understand what inverse sine is.
What is the angle that has the sine of 1/2?
Yeah. What angle has the sine of a half? Exactly. What angle? You're finding an angle. Okay, so you're going to go to the sine column. You're going to look for a half. And then you're going to find angle. Okay, so going down the sine column, what's the first angle that has 1/2 in it? 30, which is the same as negative 330. And does 1/2 come up anywhere else?
150.
Yes, 150. So this time we found the answer twice. So we got 4 possible choices. 30, negative 330, 150, negative 210. Technically they are all correct. But we're deciding on one answer. What's the one answer we would pick out of those 4? 30, because it's between what? Negative 90 and 90. Yep. So we're going to go with the 30. Or, if they wanted radians, what is 30 degrees in radians?
Pi over 6.
Pi over 6. Perfect. Whoops. Wait, did my page move on me? Or I messed up. 30 degrees is pi over 6. Alright, let's try this one. Inverse sine of root 2 over 2. So I want to know what angle can I take the sine of, and it comes out to root 2 over 2. We'll circle all our options. Yep, where's the first time you see it?
45.
Yep, you see it at 45.
135.
And root 2 over 2 happens again. So you got 4 choices. 45, negative 315. 135, negative 225. Which one would we pick?
45.
Yep, 45. It's the only one between negative 90 and 90. Alright, now I'll try one more with inverse sine. The inverse sine of negative root 3 over 2. Inverse sine negative root 3 over 2. Now, one thing I could do is I could ask you, list all 4 possible answers, and then tell me which one we would choose out of the 4. So the calculator can tell you which one you would choose out of the 4, but it couldn't tell you the other ones. Only this chart can tell you that. All right. So where do we see negative root 3 over 2?
60 degrees.
You said, can you say that again?
Is it 60 degrees?
That's positive root 3 over 2. We're looking for negative.
300.
300. Yep, I'd agree with that one. All right. Anywhere else?
I said 240, not 300, but yeah.
Oh, I thought I heard someone say 300 at the same time. Yeah. All right. So those are the 4 possible choices. What is the one that we're going to go with for the one answer?
Negative 60.
We're going with the negative 60. Yep. Okay. So any question how to use that chart to do inverse sine? Okay, so all you need to do for the homework part of that, you can just pause the video, 152 or anywhere that I had the chart on the screen, and then you can just look at the chart. Okay. And you don't need to print it out for the test. It's already in the Edgelastic question. All right, let's try this one. Inverse cosine of 0. All right, now we got to be careful. We're not negative 90 to 90 anymore. What are we thinking about with inverse cosine?
0 to 180.
Right. If you go negative 90 to 90, you're going to have a problem. It's not going to work. You've got to go 0 to 180. All right. So where do we see a 0 in the cosine column?
0. 0 on that 360. Oh wait, sorry.
270.
270. Let's see. 0 in the cosine column. Yep.
90. Oh wait, never mind, that doesn't matter.
And where else?
90.
Yep. 0 in the cosine column right there. Okay. So which answer? 90, negative 90, 270, or negative 270?
90.
90. Right. And if you're thinking, well, wait a minute, there's a negative 90 and there's a 90. How do I know which one? You're not between negative 90 and 90. 0 to 180. So you're definitely going with the 90. Or, what's that the same as in radians?
Pi over 2.
Pi over 2. Yep. Okay. Let's try inverse cosine of negative 1/2. And the negative does make a difference. You gotta be careful. So always look for the negative 1/2. where do we see a negative 1/2?
120.
All right, we get the 120, 240. Anywhere else?
240.
Yep, 240. Okay, so we got 4 choices. Which one do we go with?
120.
120, because it's between what?
0.
It's between 0 and 180. Yep. 120. And I'll try one more with inverse cosine. So inverse cosine of negative root 2 over 2. Okay. So where do we see the inverse under the cosine column? Where do you see negative root 2 over 2?
That's 225.
225 negative root 2 over 2. Yep. And where else?
135.
135. Yep. Okay. So we got 135, negative 225, negative 135, and 225. Which one do we go with?
135.
135. Yep. Stick with between 0 and 180. Okay. So any question on looking up inverse cosine in that chart? All right. Let's try a couple just with inverse tangent. Just 2. So inverse tangent of square root 3 and inverse tangent of root 3 over 3. All right. We'll start with square root of 3. What are our possible choices for inverse tangent root 3? Yep.
60, negative 300,
60, negative 300. Yep.
or 240, negative 120.
Root 3, 240, negative 120. Yep. Okay. Inverse tangent. What do we got to stay between?
Negative 90 and 90 we can't include it.
Right, negative 90 to 90, but it'll never equal it because that would be undefined. Yep. So what's our answer for inverse tangent square root 3?
60.
Yep, it's going to be 60. So based on that, if I took the tangent of 60, what would I get? Root 3. Okay, root 3. So the inverse tangent of root 3 is 60 degrees. Tangent of 60 is root 3. Okay, and how about the last one? Inverse tangent, negative root 3 over 3.
150, negative 240.
So we got the 150, negative 240. Negative 210.
330.
And let's go negative root 3 over 3. Yep. Okay. So which one?
Negative 30.
Yeah, because we got to be between negative 90 and 90. And negative 30 is the only one. Okay. Any question on that? Now, what if I asked you for this one? Inverse tangent, 0.25. Where is that in the table?
Wouldn't it be mentioned as 1/4?
What is it?
Wouldn't it be mentioned as 1/4?
Okay, yeah, you could write 0.25 or 1/4. Yeah. Yep. So where is that in the table?
It'd be undefined. Oh.
Square root 3 over 3? That's about 0.57.
Undefined.
So that's not 0.25. Yeah?
Undefined.
Nope, it's not undefined. So where is 0.25 in the tangent column?
It's not.
It's what?
It's not.
What do you mean it's not?
Because
It's not.
It's not there.
Nope.
Okay, 0.25 is never in the inverse, is never in the tangent column. How about, what about, let's say, inverse sine of 0.361?
Nope.
Where is 0.361?
Not on there.
It's not on there. Okay, so what are the angles that are on here? If you kind of had to generalize all the angles that you see in the table, what do they all have in common?
They're all in the unit square circle.
They're all in the unit circle. And what kind of angles did we study on the unit circle?
Piece of one.
Or the radius of the circle is 1, but what were the kinds of angles that we studied on that circle?
30, 45.
Right, anything that was a multiple of 30 or 45. So in this chart, you will only find angles that are multiples of 30 and 45. I mean, I could have made a bigger chart, but I didn't. I just picked angles that were multiples of 30 and 45. That means when you look at the numbers in the different columns, you will only see numbers that came up when we did the unit circle. Numbers from the unit circle are 1s, 0s, negative 1s, 1/2s, negative 1/2, root 2s, root 3s, negative root 2s, negative root 3s, and undefined. Those are pretty much the only kind of numbers that you're going to see in this table. So, if I ask you to do a problem, and that number that I just circled in red is not one of the numbers I just said, root 3s, root 2s, 0.5s, negative 0.5, things like that, then the only way to do it is to use the calculator. So if you can't find the answer in the table, then we're going to use a calculator. So let's see if somebody can tell me how to do this. Okay. First, can someone read that to me? What does it say? Yep.
The inverse sine of 0.65 is...
Yep. It says the inverse sine of 0.65. Now, well, what is inverse trig used to help you find? More general. Inverse trig is used to find an angle. Okay? So this number right here, that's not a degree or a radian. That number is not an angle at all. That number, it's just a number. The answer that you get, that is the angle. So you have to decide beforehand, do you want your angle in radians or degrees? And you need to set your mode. Okay? But this 0.65 is not an angle. You're figuring out the angle. Okay? So let's say I want it in degrees. Is my calculator in the right mode?
No. Yes.
Yeah.
Yeah. How do I type in inverse sine of 0.65?
You can decide 0.65.
Yep. And then what?
You say
Yeah, I see that. Okay, so if we round to 2 decimal places, what is the angle that has a sine of 0.65?
40, 45, 40.
Yep. So it's 40 40.54 degrees. So if I take the sine of 40.54, what should I get?
0.65.
I should get 0.65. How come I got 0.64998?
Because you round up.
Yeah, because it wasn't 40.54. Okay, none of these come out exact. The only ones that come out exact are the ones from the table. All right. How about negative 0.24? If you look at your table, is negative 0.24 a number in the cosine column? No, it's not a number we ever worked with on the unit circle. Okay. So let's do this one in degrees. How do I type it in? Second cosine. Negative 0.24. So that's 103.87. Now I want it in radians. Now I could do it by hand. I could multiply by pi, divide by 180. But how can I have the calculator just do it for me in radians? Switch the mode to radians. And then just type it in again. 1.81 radians. So 103.87 degrees or 1.81 radians. Any question on that? All right. Let's try this one. Inverse tangent of 34.3. All right. If you go back to that table, is 34.3 a number that ever comes up in the tangent column? Nope. So is this 34.3, is that a degree or a radian?
New.
Neither. This is not an angle. It's just a number. The angle is going to be in that box. Okay, so it's neither. Let's do this problem and get the answer in degrees this time. Okay, so first thing I'd have to do to get degrees is what? Switch the mode. Put it back in degrees. And what would we type in? Second tangent. 34.3. So that's 88.33 degrees. All right, so I asked this earlier, and I'll ask it one more time because it's going to help us to do something in a second. Inverse tangent of 34.3. How could you word that for somebody that doesn't understand what inverse trig means? What is this really asking? Yeah.
What angle gives you the tangent of... What angle will give you the tangent of itself being 34.3?
I like the part with tangent. Can you say it one more time? Like, tell me what to write, left to right.
Tangent of 88.33 degrees.
All right, I'm going to put a question mark because we didn't know that at first.
Equals 34.3.
Exactly. What angle can you take the tangent of and get 34.3? Okay, that's going to be important to be able to think about in a second. Because now I'm going to ask you for that. The inverse secant of 1.45. Is there a button on there that says SEC to the negative 1? No. We're going to have to figure out how to do it with another button. We've kind of done something like this before, but not exactly. So we got to be a little careful. Yeah?
Is it the 1 over sine?
Well, kind of. We're going to do something with 1 over, but not exactly like we did before. Can somebody tell me can reword this question for me? I want to reword it in a way that if I don't know what inverse trig means, I want to have something right here. How can we reword that question? Alex?
Secant of an angle equals 1.45.
Yes. The secant of what angle is 1.45? Yep. Now, there's a function that's connected to secant. And we talked about this, I think, when we did the unit circle. Does anybody remember what function is connected with it? Yes. If asking what angle gives you a secant of 1.45 is exactly the same as asking a different question, this question. But what would be on this side? If the secant has to equal 1.45, what would the cosine have to equal?
The inverse of 1.45.
Not the inverse of 1.45. No, not negative 1.45.
1 over 1.45?
1 over that. So remember, when we had like sine, cosine, tangent on the left, cosecant, secant, cotangent on the right. If we knew something on the left, we had to flip it to get the one on the right. So if we know that the cosine is 1 over 1.45, when we flip that, that's the secant. Okay. All right. So any question on that? Now, can somebody reword this for me? But what I want to do now is reword it back so it has inverse trig. So we reworded it to get rid of inverse trig, changed it to an equivalent question because we have a button for cosine on the calculator. Now change it back to something with a -1 from this box in black. Yep.
Inverse cosine of 1 over 1.45 equals an angle.
Perfect. Equals, and that's what we're trying to figure out. So the trick is, when you're trying to do inverse secant, cosecant, or cotangent, you do flip something, but you don't flip the entire box. You only flip what's in the parentheses. That's what you flip. Flip what's in the parentheses and change this to the function that it's connected with. All right, let's type that in. So inverse cosine, 1 over 1.45. There's no other way to do inverse secant on the calculator. That's all you can do. There's no other button. It's 46 point, if we round up, 46.40. Okay, let's try this. Is there an inverse cosecant button on the calculator? No. Then we got to do two things. Flip that and change that. Okay, let's start with the change. What function is connected to cosecant that we can flip? Sine. So we're going to change it. We're going to change the function name, just like we did here. Change the function name. And what are we going to do with the 2.6?
Put a 1 over.
Put a 1 over it. Flip it. That's how you have to do inverse cosecant. Okay. So inverse sine, 1 over 2.6. We get 22.62. Alright, let's try one more. Okay, inverse cotangent. If we have a button for it, we should type it in. Just put it in right away. Do we have a button for it? No. Nope, no button. So you got to do two things. Change, flip. Cotangent. What trig function can you change it to?
Tangent.
Yep. So you change it to the one that it's connected with when you flip it. And now don't put 0.35. What's going to go inside here? 1 over 0.35. Yep. Okay, so second, inverse tangent, 1 over 0.35. 70.71 degrees. Any question on that one? What if I did this one? Inverse sine of 0.274. Okay, do we do it like the last one? Change and flip. Why not? Why not do the change and the flip?
Because you have the button.
Yeah, I got the button for that one. So I don't have to do anything. Inverse sine 0.2 or whatever I said, 274. 15.90. Okay, so you only got to do the change and the flip when you don't have the button. All right, so any question on how to use a calculator to do any of the 6 inverse trig functions, or how to use that table? Okay, and again, there's several points in the video where I put the full table on the screen, so just remember the time for one of the points, and you can pause it. Or pause it on your phone and take a screenshot or something. All right, so that's it for 3.1 part 1. Okay, so homework, you will need a calculator for some of it, and the rest of it you can use the chart. So it's 13 to 17, 19, 20. And then 22 to 31 and 33, and that's all. So it's all the questions, no odds or evens, just all. All right, you got just under 25 minutes or so right now. So please use the time to try to get a little bit done on it. And then next time we have class, we'll finish up this section.
Alright,